Good evening, one and all present here. On behalf of the Institution of Engineers India Serum Local Center, I extend my warm greetings to you all. It gives me immense pleasure to welcome you to this 94th special webinar under the Engineers Talk weekly lecture series organized under the aegis of the Computer Engineering Division Board of IEI today. At the outset, I take great pride in sharing that this year we are marks the 30th anniversary of our Salem Local Center. Over these again 3 decades, IEI Salem has been a beacon of professional growth, academic enrichment, and social service. We have consistently strived to bring together academicians, researchers, industry professionals, and students to exchange knowledge and contribute to the nation's development. ISLM Local Center has been very active in organizing seminars, workshops, guest lectures, student-centric programs, industry institute interactions, professional development courses, R&D initiatives, and outreach activities. We are also proud of our flagship program, the Engineers Talk Series, which has now reached its 94th session. This weekly online lecture series has been a hallmark of our center, bringing eminent experts from across India and abroad to share their expertise on emerging technologies, innovations, and sustainable practices. Today's session is indeed special as we are honored to have with us Dr. Lavak Singh Sir, ITS, past chairman of Punjab Chandigarh State Center, IEI, as our distinguished chief guest and keynote speaker. Also, sir is my actually one advisor, we can say again philosopher, a good friend to mine also. We are grateful to him for accepting our invitation and going to deliver a wonderful talk on a very timely and significant topic, blockchain beyond bitcoins, applications to build trust and transparency for sustainability. Before moving forward, I would like to take this opportunity to express my heartfelt appreciation and gratitude to our Honorary Secretary, Dr. C. Daumani Ma'am, for his constant support, tireless efforts, and dedication in strengthening the activities of our IESL Local Center. To all our IESL Local Center committee members who have always extended their cooperation and guidance in all our endeavors. To the engineers talk team members who work silently and sincerely every week to make this knowledge sharing initiative very successful. For that, I deliver my special thanks, special word of thanks to Engineer Armugam sir, whose encouragement, vision, and participation with again wise counsel continue to inspire us. Also, to Mr. Tiago, who has been constantly putting in behind the screen efforts in cooperation, coordination, communication, and executing of these again weekly sessions. Your contributions are deeply valued and appreciated. As we move towards the 100th session milestone of Engineers Talk, we are proud that these again sessions not only spread technical knowledge but also foster collaboration, motivate young engineers, and uphold the legacy of IEA in serving the engineering fraternity and society at large. I warmly welcome each one of you once again and encourage you to actively participate in today's webinar, interact with our speaker, and make the most of this opportunity. Sir is again well again deserved, again well experienced. So I request you all to with it, let us look forward to an enlightening and thought-provoking sessions by our today's guest speaker. Thank you. Jai Hind.
Thank you very much, sir. Now, it's my pleasure to introduce the chief guest of today, Dr. Lab Singh. Dr. Lab Singh is graduated in BSc Engineering in Chandigarh and did his MBA and PhD in Punjabi University, Patiala. He is an awardee of D.Lit Honoris Causa of Theophany University, Haiti. He is an ITS officer of 1979 batch from Indian Engineering Services. He has served nearly 37 years in telecom sector and retired in 2017 as advisor, the Department of Telecom. He has vast experience of tender processing and awarding the telecom related works of projects and maintenance. He is also an IEI certified engineer arbitrator. He has co-authored a book on Industry 1.0 to 7.0. He has collaborated for 2 patents apart from writing about 20 articles and book chapters on emerging technologies and circular economy. He is past chairman of Institution of Engineers India, Punjab and Chandigarh chapter, and a member in various prestigious organizations like Institution of Electronics and Telecommunication Engineers and Institution of Engineers India. And he is member in Global Goodwill Ambassador Foundation, USA, member Cybersecurity Association of India, and he has been mentoring and playing business consultancy roles in Blockchain for Productivity Forum and IPv6 Forum, New Delhi, Cybersecurity Security Society, IIT Kanpur, Divya Slokam Media Network Canada for Content Strategy, India Blockchain Alliance, and other popular forums. He is founder, CEO of NextGen Foscom Foundation and MSME for skill development. He is very passionate about promoting the UN mission on sustainable development goals by leveraging IT. He is an active member and LinkedIn with 16,000 followers. With these words of introduction, I would like to invite Dr. Lab Singh to present on topic blockchain beyond bitcoins, applications to build trust and transparency for sustainability. Over to Dr. Lab Singh. Please, sir.
Yeah, good evening. Thank you for a very beautiful introduction. Is there any echo?
Yes, sir.
Actually, I think I opened more than one probably. Is it okay now? No. There is echo in this.
Sir, actually, it's a problem with your side.
I see. So what I will do is, I will join again. And let me see. Yeah, I don't. Is my screen visible?
Yes, sir. Visible, sir.
It is visible. But I think that the echo part is still there. So I have to probably I think that there's some audio setting problem is there. Let me try to solve it.
Still, it's echoing, sir.
Yeah. Is it okay now? No. Not still. I think.
Yes, sir, it's not okay
Still
now.
echoing.
I think I'll just join again probably. I'll
Yes,
just
sir.
join again. Yeah.
Okay, okay, sir, sure.
Hello. Hello. Still it is same thing. Hello. Am I audible now?
Yes, sir, perfectly.
Now I think echo is not there, no?
Yes, sir, yes, sir.
So we can now start. So I'll just try. Now this screen is there with you?
No, sir.
Screen. Okay, I'll share it again. No problem.
Yes, sir.
How is it? Is it there?
Visible, sir.
Visible, no? Okay. So I'll start. You are recording it also?
Yes,
Or
sir. Recording is going on.
Acha, recording is going. Okay, okay. That's
Yes.
so. Thank you very much, everybody, for a great introduction and little hold up was there. So I really feel a little, sorry for that. So I'll just start with the, you know, straight away with the, uh, that slideshow. Now is it okay?
Okay, sir.
Is it okay?
Yes, sir. Okay.
Okay, right. So, from here, famous scientist that is not the person that I admire. However, those I find it here is focused on this concept of spectrum. Hello, am I audible?
Audible, sir.
Okay, okay. So thank you very much, and let me congratulate Salem Center for its 34th anniversary and 30th anniversary and 94th lecture which has been organized. And I welcome all the senior IEI officers, representatives from Kolkata, and this honorary secretary and chairman, all members of the committee, and the students, faculty as well. I think this topic must interest every one of you, and I'm sure that we will definitely like understand the subject better by sharing our knowledge. I hope I'm visible. Should I continue?
Yes, sir.
Okay. Uh, so the topic is the blockchain beyond Bitcoin's applications to build trust and transparency for sustainability. Normally the blockchain is connected with Bitcoins, but we have much more than that. So we'll see in the coming slides. Like this great scholar Brock Pierce, he said that every smart person that I admire in the world and those I semi-fear is focused on this concept of crypto for a reason. They understand that this is the driving force of the fourth industrial revolution, that is steam engine, electricity, then microchip, and now blockchain and crypto. That is the fourth industrial revolution. Introduction about blockchain is that it is underlying technology for cryptocurrencies such as Bitcoin. The first blockchain was created in 2009 by an anonymous person or group of people under the name Satoshi Nakamoto. Cryptocurrencies and blockchain technologies are used as a way to secure, track transactions. So some use cases for blockchain technology include tracking the provenance of food products. That means the whole chain from the production to the delivery. So provenance of food products, managing the land titles, auditing supply chains, and issuing digital certificates. That is the verification of the credentials. So several top countries are developing blockchain applications, including China, Japan, Estonia, and of course now India also. Fred Arison has said that everything will be tokenized and connected by a blockchain one day. So this is this forecasting of the future trend. It is really being met by the interest people are showing. And how blockchain is related with security, that we will now see in this slide. So blockchains manage a large scale record of transactions and additional data wrapped in several layers of data security. As a result, these systems are generally regarded as safe and secure. A blockchain is a digital ledger of transactions. This is to be noted, managed and updated by a distributed network of computers. Distributed network of computers. But blockchain uses the three principles of number one, cryptography, number two, decentralization, and number three, consensus. This also we'll see in detail in the coming slides. To create a highly secure underlying software system that is nearly impossible to tamper with. So it is a tamper-proof system. There is no single point of failure, and a single user cannot change the transaction records. That's called immutability. So these are the characteristics of blockchain. Number one is decentralization. Blockchain technology allows for a decentralized distributed ledger of transactions, removing the need for a central authority. So here the central authority is no more there in blockchain network. Immutability. So once the data is recorded on a blockchain, it cannot be altered, providing a high level of security and trust. Third is the smart contracts. Blockchain technology enables the creation of self-executing smart contracts. Self-executing. This is to be noted, that can facilitate and automate the complex transactions. This is a simplified diagram in which a blockchain is shown. Like the concept is clear from here. So
Sir?
blockchain is yes, please. Yes.
The screen is not visible, sir.
Screen is not visible. Is
Yes,
it
sir.
now not visible, or earlier also it was not there?
Initially, it's visible, sir, but after that, it will went out.
Oh, I see. So this is not, you are not able to see this? Is it not there?
Yes, sir. Not
Should I?
visible.
Not visible. Okay.
Yes, sir.
Is it visible? Not visible.
Not visible, sir.
What about this? Now? How about this now?
Not visible, sir.
Is it visible?
Not visible, sir.
Not visible. Okay. So I think I will try to share it once again. Mm. Is it visible now?
No, sir.
No. Okay. So I'll do it. Try to.
Now visible, sir.
Now it is visible, huh? Okay.
Yes, sir. Yes, sir.
Okay. But it is not full slide. I think full screen नहीं है अभी ना? Is it full screen?
No, sir.
Yes, sir. It is first screen, first page.
First page, but not full screen, na?
Not in slideshow, sir. Yes, sir.
Okay. Yes. Is it okay now?
Yes, sir. Okay, sir.
Okay. So we'll come back to the same slide where we left, you know. So here we were, like blockchain simplified diagram is there. It is showing blocks and there is a angle of security also shown here. Then you know the data on the blockchain, it cannot be changed, it cannot be hacked, or it cannot be even cheated also because of the reason of security. So like which problem is solved by blockchain? So starting from preventing fraud to securing transactions and improving the supply chain to easing the government operations, blockchain technology solves the biggest problems which were not possible by any other technology before. So blockchain is a shared immutable ledger that facilitates the process of recording transactions and tracking assets in a business network. An asset can be tangible, it can be a house, car, cash, or land, or intangible, intellectual property, patents, copyrights, and branding extra. I hope it's okay now. The screen is there now.
Yes, sir. Okay, sir.
Okay. So now we were talking of transactions. So what is the transaction in blockchain concept? Let us try to understand that. A transaction in blockchain is the transfer of information or value digitally between the participants recorded permanently on a decentralized ledger without intermediaries. Like simple example is that if Alice sends 1 Bitcoin to Bob, the blockchain validates and records it. And example 2 is a smart contract automatically transfer the ownership of digital artwork after payment. So these are small examples which show that the reliability, security, and transparency in the blockchain system. And all the transactions are immutable, transparent, and trustless. So a transaction in blockchain is like a digital record. Kindly note, digital record of value or information. It need not be a currency always. It can be information about any digital asset also. So these are the basic components of a blockchain network. It is distributed ledger, then peer-to-peer network, which we will discuss in detail. Consensus mechanism, various methods are there. We'll try to share that also. Then cryptography and virtual machine, which is very important component of the whole network. And what is DLT? That is called distributed ledger technology. So this distributed decentralized database managed by multiple participants. So the whole ledger is available with all the participants. That's why it's called distributed. And it is decentralized because it is not controlled by any central agency. So these are the basic points about DLT. So this is also depicted accordingly, like each block in the chain, it has transactions, contain a number of transactions, and every time a new transaction occurs on the blockchain, a record that transaction is added to the every participant's ledger. So whenever transaction is entered in a block, it is available with every participant. Participants are called peers or nodes. That also we'll discuss. So this is how the block in a blockchain looks like. Is that on the top is the block header, then is the block number, then timestamp when the transaction was made, which transaction was made when, time is there. Then previous block hash is there, then current block hash. So that is why it is chained. They are connected with that information in terms of hashes with the previous block and the current block. And then nonce, that also we will understand. Then various transaction data is there. So in a blockchain, nonce is basically a short for a number used once. So it's a random or unique value. Nonce is a random and unique value that is used only one time. In Bitcoin mining, the nonce is a number that miners change repeatedly when trying to find a hash value that meets the difficulty target. So miners are the people who allow the transaction to be entered in the blockchain. So this is the process they use. Every time the nonce is changed, the block's hash changes. So if the hash starts with enough leading zeros, meeting the difficulty requirement, the block is accepted. So they keep on changing this number, nonce. So when it matches with kind of zeros, earlier a number of zeros, which of course are already prescribed, then only the transaction is accepted or the block is accepted. It prevents replay attacks and ensures freshness in the cryptographic communication. Think of nonce like a lucky ticket number. So this is just an analogy, trying to explain that miners keep changing. It is a lucky ticket number which miners keep changing until they find the right one that wins the lottery of adding a block. And this diagram, my dear, is explaining the DLT in general. It's programmable, it's secure, it is anonymous, it is unanimous, it is time stamped. Unanimous means everybody has agreed, to accept the block, and it is time stamped. So a transaction timestamp is recorded on a block, so that it helps in traceability. Then immutability. any validated records are irreversible and cannot be changed. That's why it is trustworthy. So and the last one is the distributed nature of DLT. That's all network participants have a copy of the ledger for complete transparency. That is the basic quality of blockchain technology. Now we will just learn about smart contracts. So Ethereum is a blockchain platform, and the most popular blockchain it is for running the smart contracts is Ethereum. On Ethereum, smart contracts are typically written in a Turing complete programming language that is called Solidity and compiled into low-level bytecodes to be executed by Ethereum virtual machine. And a virtual machine is a part of the blockchain network, which we have already seen. So bytecode, what is bytecode? Bytecode, it's called a P code also. It's a form of instruction set designed for efficient execution by a software interpreter. It serves as a bridge between human written source code and the native machine code that the CPU understands. So source code and machine code, in between is the bytecode. In brief, I can say. So this is the example of Ethereum smart contract. It's very simple example is given. Like the best metaphor for a smart contract is a vending machine, as described by Nick Jabo. With the right inputs, a certain output is granted. So this is the smart contract. With the right input, the certain output is granted. So this logic is programmed into a vending machine. If someone inserts $2 and then presses B4, then the machine dispenses the package of cookies held in the B4 slot. So this is a small example. Like it can be repeated, but it has to happen. And that the program by which that machine is doing it, that is equivalent to the smart contract. So if I pay $2, I must get a package of cookies. That is a smart contract. Behind that smart contract is working behind that. Now let us try to understand these very important points about solidity, low bytecode, and Turing complete. So Solidity is a programming language used to write smart contracts on blockchains like Ethereum. These contracts are small programs that automatically execute rules without middleman. This is to be understood. That's why its function is decentralized. That blockchain is decentralized because there is no middleman required. When written in Solidity, the code is compiled into low-level bytecode, which is like a machine language that the blockchain's virtual machine can understand. So bytecode is for the virtual machine, one can say. So this makes it efficient and secure to run on many computers in the network. Solidity and the EVM are Turing complete, meaning they can, in theory, perform any computation if given enough time and resources. In short, Solidity compiled to bytecode runs on a Turing complete blockchain system. And this is the actually example. This is how it looks like, simple Solidity smart contract, how it looks like on the screen that I've tried to show here. Now another little more about Turing complete. What is a Turing complete? A system is called Turing complete if it can perform any possible computation given enough time and memory. This means it can simulate a Turing machine, the theoretical model of a computer. Most programming languages like Python, Solidity, Java, they are Turing complete because they can use loops, conditions, and memory to solve complex problems. For example, Solidity is Turing complete, so smart contracts can run any logic like banking rules, games, or voting. This is a sample of Turing complete. Like this is a simple example of how to add two numbers. So this is just I've shown that how it will look like when we write a program in Turing. So this is a very important concept in blockchain. It is called General's dilemma, or it is also based on Byzantine generals problem. So what is this? Let us try to understand. So this describes the challenge of reaching agreement in a distributed network, where the participants may not trust each other. So we have to create trust by reaching an agreement with all the participants. So the general's dilemma is, imagine the generals surrounding the city. They must all attack or retreat together. So how do they know? Because they are at different places in the city. Can they retreat or should they attack? So, but the messengers could be delayed or dishonest. So in blockchain. So this problem appears as how nodes agree on the state of transactions without a central authority. So all the participants have to agree to work together. That is in a simple way, that is the important point. So consensus mechanism like proof of work, proof of stake, they solve this dilemma by ensuring all honest participants eventually reach the same trustworthy ledger. So then only the block is allowed to be chained after this proof of work is done. This consensus mechanism we'll also see in detail. So this is something in between. I've tried to sandwich it. This is the wisdom basically. With the internet and blockchain, everything is changed. It is the future of content. So that is the importance of this technology. Now we'll talk of a few methods of consensus mechanism. How it works. What are the advantages? What are the limitations? So my dear, number one is the proof of work. So miners, they solve complex puzzles using computing powers. First, solver validates the transactions, then secure, widely tested and decentralized. Then high energy, it's because they have to make a lot of alterations and iterations by to solve the problem. The energy used is high in this case, and that is why the transactions are slower. So this is a basically, in fact, it is a sort of a limitation. So the proof of work is it is done by the solving of the puzzles, and those miners, they get the credit for that. And then once miners clear that, okay, it's fine. It's after solving the puzzle only, they will allow that block to be entered in the blockchain. So this is also explained here. Mining in blockchain is the process where powerful computers solve complex mathematical puzzles to validate and to add new transactions into a block. So this process of mining, it secures the network, prevents double spending, and rewards the miners, usually in cryptocurrency or Bitcoin, for their effort. Mining is mainly used in proof of work blockchains, such as Bitcoin. However, not all blockchains use mining. So this is to be noted. Mining is not used in all kind of blockchains. It is mainly used in the Bitcoins. Many newer systems adopt alternatives like proof of stake, proof of authority, which validate the transaction without energy heavy mining. In the last slide, we saw that energy consumption in proof of work is more. So these are the methods where energy consumption is less, energy requirement is less. Thus, mining is essential for proof of work networks, but not necessarily for all the blockchain applications. So this is to be noted. This is the second, type of consensus mechanism, that is proof of stake. So validators chosen to confirm blocks based on the coin staked. But how many coins they are staking for that, accordingly, they are chosen. Then validators are here, miners. It is same thing. Energy efficient, scalable, eco-friendly. It favors the wealthy holders, less tested. So that means the person who can afford to pay the coins, he is made to validate in this case. And this one is the delegated proof of stake. So token holders vote for the delegates who validate transactions. So this is how the proof of stake is carried out by the delegated people. And token holders will vote for the delegates. So it is fast transactions, it is democratic input, and risk of centralization is there in this case, and reliance on few nodes only. So this is, you can say, limitation as well. Then proof of authority. So trusted authorities validate blocks using reputation instead of coins. So here, that earlier miners they used to earn the coins from the by solving the puzzles. Then that delegated ones, they were able to pay because they could afford, so they were able to select the validators. But here it is out of the authority. So it is more efficient, it is low energy, good for private companies, private blockchains. Then centralized trust and not fully decentralized. Not fully decentralized. So last one is the proof of history. So cryptographic timestamps prove order of events, speeding up consensus. So we see the history, and to ensure that how we can rely on the on the permission to be given for a block to be entered in the blockchain. So it is very fast, high performance networks, complex design, but limited adoption is there. And similarly, there is another consensus mechanism. Some of you may be knowing, that is called proof of burn also. So many new techniques are coming, because the energy consumption is a challenge to find out. And then, of course, at the same time, you want to ensure the decentralization also. So this is how the hash is, the role of hash in blockchain. Blockchain is a type of DLT, that is distributed ledger technology, in which transactions are recorded with an immutable cryptographic signature. So these transactions are recorded where you cannot play with that hash. So hash is also shown here. It is 64 character length, and it is using the method of SHA 256. So this also we'll try to understand what is SHA 256. So it's a cryptographic hash function that takes any input, maybe it is text or files, and produces a fixed 256-bit output. That is, its length is 64 character hexadecimal string. It's like a digital fingerprint, unique and irreversible. For example, the input for hello is given here. These are the 64 characters. So this is how it is shown on the screen, one can see. Now, these are the key characteristics of a blockchain hash. That is fixed length. Regardless of the input size, the output is always 64 characters. It is unique. Even a tiny change in the input gives a completely different hash. So if somebody wants to enter a transaction without the consensus, then the hash will change, and then it will not be allowed to be entered. That blockchain will be thrown out. Block will be thrown out of the blockchain. So this is again another example of, if we write hello blockchain, then this is the hash displayed here. Then it is irreversible. This hash is irreversible. You cannot get back the original data from the hash. Then secure, used for block identification, linking blocks, and ensuring immutability. So this is the reason why this is immutable. This the transactions. Yes, please. Hello. Can somebody tell me how much time is there? Another maybe half an hour is there with us. Hello.
Sir, yes, sir. You continue, sir.
Okay, because I will have another 30 slides, I think. Okay.
Okay, sir.
Thank you. Now, why this blockchain is tamper-proof? So a blockchain is essentially a digital ledger of transactions that is duplicated and distributed across the entire network of computer systems on the blockchain. So in a blockchain, each block contains its own hash, the hash of the previous block and the transaction data. This chaining via hashes makes the blockchain tamper-proof. Of course, this was already discussed also, but here it is especially the stresses on the tamper-proof. Nobody can probably hack into that data, which is on the blockchain. So the old question, is it in the database? Now that is replaced by, is it on the blockchain? So this is a very nice quote said by William Mogier. The old question, which was we used to ask, is it in the database? Now it will be replaced by, is it on the blockchain? So this is the little comparison is done between Bitcoin and blockchain, because sometimes people confuse, or they say that Bitcoin is same as blockchain. So I'm trying to clarify this. So blockchain is the technology that enables existence of cryptocurrencies, among other things. Bitcoin is the name of the best known cryptocurrency, the one for which the blockchain technology was created. So Bitcoin is a cryptocurrency while blockchain is a distributed database. So this is to be understood. Bitcoin, only we talk of cryptocurrency, but blockchain is a distributed database. Bitcoin is powered by blockchain technology, no doubt. But blockchain has found many more uses beyond Bitcoin. So Bitcoin promotes anonymity while blockchain is about transparency. So this is beautifully said here. And here is the comparison I have made. Like in case of identity, in case of Bitcoin, it uses valid addresses, not real names. But in case of blockchain, it regards open. It is open. Its records are open for all, though identities are hidden. Similarly, privacy, pseudonymous activity is there, but not personal information in case of Bitcoin. But in blockchain, all transactions are public and permanent. They cannot be changed. So similarly, about traceability, focus, and the example is also given, like here in Bitcoin, we talk of like send the money from address A to address B. But here the identity is not disclosed. The name of the person or it's not disclosed. As that's why anonymity is there. But in block, it shows all the transactions. So that is the difference. All the transactions and hashes. Now we will talk in the next series slides about the peer-to-peer system. So Bitcoin is a form of digital currency created in 2009 that is created and distributed on a peer-to-peer basis. It has no central bank. So central authority is not there in the whole concept. Transactions are conducted directly between the individuals, and these individuals are called, we can say these are called peers. Peer comes from the Latin word, it is par. Word is par, which means equal. So all the peers are at the equal level. They play at the equal level, So Bitcoin is only the first use case of blockchain, and it is the world's first cryptocurrency, which appeared in June 2009, as we said earlier also. So Bitcoin accounts for nearly 40% of the entire cryptocurrency. So that is the basically importance. It is most popular, technology. So peer-to-peer, what is peer-to-peer? It refers to the direct exchange of some assets, such as digital currency, between the individual parties without the involvement of a central authority. A strictly peer-to-peer exchange of currency was the primary goal driving the creation of Bitcoin, the most widely used cryptocurrency. So that means there was no middleman in the whole transaction. Now, peer. A peer is capable of hosting more than one ledger. So it doesn't mean that only one peer to one ledger will be there. It can own more than one ledger also, which is useful because it allows for a flexible system design where a single peer can belong to multiple channels in a fabric network. So maybe if a fabric network is running projects on health, projects on governance, or maybe project on verifiable documents. So a peer can participate in all of those. In the simplest configuration, a peer hosts a single ledger and therefore belongs to a single channel. So that is the simplest configuration, one-to-one. But it can have more than one host this thing also, like more than one ledgers. This is the last slide on peer and node. So for what I understand, a node is basically a machine which inside is running the HL, that is hyperledger fabric binaries, and is communicating with other machines belonging to the same network. So a peer is the type of the node in particular. So as a orderer, the one which put the transaction in a certain order for the for the insert in the ledger. So order means you are putting the instructions in the ledger. But the machine behind that which is working is called node. So in Ethereum, nodes use a peer-to-peer network to communicate, where nodes send or receive the data to or from any other directly connected peer. So this is another quote. We believe that cryptocurrency and the use of blockchain can open up the economy to individuals and groups that have been historically excluded or ignored by the free market and financial institutions. So the meaning thereby that now more and more financial inclusion will happen with the coming up of this blockchain technology. So these are the steps taken to, how a blockchain Bitcoin process works. Number one is the create a wallet, make a digital wallet with a public key. Public key is the address, and private key is the password for the digital signatures. Second is get Bitcoin. Bitcoin you can either buy or receive or mine it. So mining involves the puzzles and creates new coins. Step 3 is send the coins. So use your wallet, enter recipient's address, sign with your private key and broadcast on the blockchain. Then step 4 is the validation. Miners, they confirm the transactions by solving puzzles and adding blocks. So miners are there to validate that whether the transaction taking place is genuine. It can be verified, So, and step 5 is the confirmation. So blockchain, once it is validated, the blockchain will update. Then the transaction becomes final and visible to everyone. There is an analogy also which is in the next slide. It is just like, sending a letter. This is very interesting. You will really like it. So you first get a mailbox. Mailbox means wallet with a lock. Lock is the private key, and address, that is the public key. So you obtain stamps from the post office. They are the bitcoins. So then you obtain stamps either buying or receiving or earning them. So you write a letter. Letter is the transaction. You write a letter, sign it, and drop it in the network mailbox. Then postman, that is in the form of miners, they race to verify your letter, because your letter is real or not. I mean, is the address given from the sender, is it okay or not? That verification has to be there. Once it is done, it is properly signed, and then only it is to be delivered. So once it is stamped and recorded in the big public diary, that is the blockchain. Public diary is basically ledger. So it is official and can't be erased. So this is we have tried to make an analogy to make it more simple, Now we'll talk of very important point of the types of blockchains. So there are 4 blockchains. One is the public blockchain, private blockchain, second consortium blockchain, and hybrid. And I've shown it in this simple table also, so that it is easily understood. So how they differ is from the point of view of the control, from the point of view of the organization involved, and the examples are also given. Like the public blockchain is its control is nature of control is it is open and it is decentralized. And examples is the Bitcoin and Ethereum. And these are owned by Ethereum Foundation and Cardano Foundation. Similarly, Second is the private blockchain. It is single entity. So its control is with a single organization. It is Hyperledger and Corda, that is the examples. And organization involved are IBM, R3, and Walmart. Similarly, consortium is a group. It is controlled by group of entities. For example, VTrade and Marco Polo. And organizations involved are HSBC, Barclays, and EWF. EWF is the Energy World Foundation. Then hybrid. So hybrid is basically mix of public and private. So we have the examples of Dragon Chain, XDC, IBM Food Trust, and organization involved are Disney, Gen Finance. I think even Microsoft is also there. Azure also. And similar to this, importance of the blockchains, types of blockchain, we are having two types of keys, which we mentioned earlier also in the example. But what are those keys? Public and private keys. In a blockchain transaction, you don't usually see the raw private key because it must always stay secret. So instead, you see, like we have public key, which is visible and used like an account number. So your public key just like your account number. And this is how it looks like in the dark. I have shown that. Then private key, it is hidden one, only used to create the digital signature that proves authenticity. So private key is your own. It is very, very secure and hidden. It is known only to the person who is there. But public key is distributed along the whole blockchain. So this is the example of private key and how digital signature is shown. And this is again shown like how public and private keys look in a transaction. So this is just to give an idea that transaction ID is there. Then from address, this is a public key hash is there. Then output it is the public key hash. And digital signature is down below. This is how it looks like. It is in that same, SHA 256. So again, blockchain technology is not just a more efficient way to settle securities. It will fundamentally change the market structure. Let us understand that. And maybe even the architecture of the internet itself will be affected by this blockchain technology. Now coming to the new concept of the token. In blockchain ecosystem, any asset that is digitally transferable between two people is called a token. This is a very general kind of definition. Any asset that is digitally transferable between two people is called a token. So these tokens are issued on a blockchain, most often on Ethereum. Depending on the properties assigned to them, they have the different classification and use. So there are many types of tokens. Tokens are digital assets defined by a project or smart contract and built on a specific blockchain. Token can be utility tokens, security tokens, or even other type of tokens are also there that we'll discuss in the next slide. Utility tokens are also called consumer or incentive tokens. So in fact, you might hear Bitcoin described as a crypto token. So Bitcoin is also called crypto token or something similar because technically all crypto assets can also be described as tokens. And similar to these tokens is the non-fungible tokens. So there is some difference between normal token and the non-fungible token. They are not changeable. They are interchangeable. NFTs are non-interchangeable. So they can have NFTs can have varied applications, and ultimately they are a way to convey ownership of anything that can be represented by data. That could be the deed to a house, the broadcast rights to a video, or an event ticket. If you have NFTs of that means you own that particular asset, which is of course shown as a digital asset. Anything remotely unique could be an NFT. So non-fungible tokens are assets like artwork, digital content, or videos that have been tokenized via blockchain. Tokens are unique identification codes created from the metadata via an encryption function. So this is how it looks. This is all digital. They tokens. They are not physically available, but they are in the form of identification codes created from metadata by encryption function. These tokens are often stored on a digital ledger. Please note this. While the assets themselves are stored in other places. So detail about asset is not important. The tokens are important, which are stored on the digital ledger. So NFTs are not interchangeable with each other. They can function as proof of authenticity and ownership in the digital world. So NFTs are very important that way. Next is blockchain and sharing of files. How files are handled on the blockchain. I've tried to show it here. How blockchain data is stored and secured. So in a blockchain storage, files are first broken apart in the process called sharding. Each shard is copied to prevent the loss of data should an error occur during the transmission. So the files are also encrypted with a private key that makes it impossible for it to be viewed by other nodes in the network. So this process has to be followed to make it secure and to ensure that the files are not lost. So they are broken into parts, and then of course further encryption is done. And how a normal user will interact with the blockchain network. For that, we need APIs. That's why I entered it here. So an API is a set of rules that lets two systems talk to each other. So in blockchain, APIs allow third-party apps, platforms, or services to connect with the blockchain without building everything from scratch. So APIs are one of the very important they are set of rules, and they are important also to bridge between the blockchain and the other services like platforms and other various platforms we are having. That is for interoperability. That's important. So these are the examples of APIs. Like Infra is one of the API which provides Ethereum and IPFS access for DApps, that decentralized apps. So Alchemy is API for Ethereum, Polygon, and other blockchains. Moralis is it simplifies the Web3 integration in case of NFTs, wallets, and decentralized finance, DeFi. And there is another API that is called Chainlink. So it connects smart contracts to the real world data, oracles. And Block Decipher is another one, that is Bitcoin and blockchain data APIs. So the note is that APIs make third-party integration with blockchain easy, fast, and reliable. So this is for the third party. Without probably APIs, you won't be able to take the full advantage of blockchain. So now comes the blockchain services are provided by the company, how they are charged. So I've tried to cover it in this small, slide. So you must have heard gas fee. Now what is gas fee? So it is a transaction cost paid to the miners or validators for processing and securing transactions. So common in this is gas fee is common in Ethereum and proof of work and proof of stake blockchains. Gas fee is charged in case of this type of blockchain. Now other type of charges are which can be there other than gas fee. That is transaction fee, which can be flat or fixed also. So some blockchains they charge a standard small fee per transaction. For example, Bitcoin. Then resource-based fees are also charged. There's networks like EOS allocate CPU, RAM, and bandwidth resources to users instead of charging per transaction. And then staking and subscription models. The users they stake tokens or pay subscriptions to use the blockchain services. That is common in enterprise and private chains. Then lastly, it is off-chain fees also. So these side chains or payment channels, for example, Lightning networks, they reduce cost by batching the transactions. So this is another type of charges, which is off-chain fees. Now I will just three to four cases are there, which I will try to explain. They can be called use cases also, and they're briefly, explained here, which of course further can be developed by the scholars, by that audience, whenever they like to, expand their knowledge in that direction. So distributed ledger technology it is used in supply chain management. So DLT can be utilized to track the provenance of goods in a supply chain. Multiple stakeholders can access and update the distributed ledger to ensure transparency and authenticity of the product origins, reducing the risk of counterfeiting and improving the traceability. So from starting point to the end, the whole supply chain is basically put on blockchain through the various methods, and then it is ensured that no product is on the way, they are not, it is not counterfeited. Its authenticity is basically maintained. And then if something has happened, then it can be traced back also, like where the things have gone bad. So this is the one application of DLT. And now this is the example of how distributed database can be used. That is in case of customer relationship management. A distributed database is employed to store customer information across multiple data centers. This ensures high availability and fault tolerance, allowing the businesses to manage customer data efficiently without relying on other things, without relying on, I would say, how it has gone now. Screen is gone?
No, sir, screen is visible, sir, but it's in the first screen, sir.
Oh, it has come as first screen now.
Yes, sir. It's also comes out from slideshow, sir.
But how it has happened? Should I start from the current slide? Okay.
Is it okay now?
Yeah, screen is there now, visible? Is it visible?
So these are the basic components.
Are you able to see the screen, please?
Yes, the screen is visible, sir.
Now, let us try to understand these very important points. Is the Achha, it is actually my recording,
Yes, sir.
No problem. I am going to that that fifth slide now, last slide which I was on. Token, NFTs, APIs. Yeah.
Yeah, this
So
one.
here we were, I think, okay.
Yes, sir.
Sorry again for the disturbance. Like we have seen that how it is distributed database is used for customer, that is CRM, right? Now we see how cryptocurrencies are shown, like how this cryptocurrency concept is used for peer-to-peer payments. So cryptocurrency like Bitcoin, they facilitate direct transactions between parties without the need for intermediaries like banks. So users can transfer funds securely and quickly across borders, making it an alternate to traditional fiat. Traditional fiat currency. Fiat currency is the currency which we normally use in rupees, dollars, and all that. That is for certain transactions. So cross-border transactions, we can use the Bitcoin. They become a universal kind of currency. But of course, there are regulatory issues in case of India. So definitely, that is another topic which can be discussed. Now, how hash graph is used in some cases, like in case of real-time gaming. So hash graphs fast and efficient consensus algorithm makes it suitable for real-time application like multiplayer gaming, which is already happening. It can maintain a shared state among players without experiencing long delays, providing a smooth gaming experience. So this is how smart contracts are used in case of insurance claims. Smart contracts can automate insurance claim processes when predefined conditions are met. That means for a flight delay exceeding a specific duration, that smart contract will come into action and then provide you the compensation in terms of payment without asking any question, because that data is already available with on the blockchain. So smart contract can automatically trigger the payout to the insured party, reducing administrative overheads and ensuring the quick claim settlement. So this is actually, if you try to introduce blockchain in a banking system, I've just tried to make a kind of steps into that. Here I'll not spend much time. We'll just go through that. It is we have to understand the potential use case in case of the banking. So identify the specific areas in banking system where blockchain technology can be applied, such as payments, cross-border transactions, or trade finance. Second step is assess the readiness of the organization. Evaluate the organization's current infrastructure, processes, and resources to determine if they are ready for blockchain implementation. Then you choose the right blockchain platform. It has to be public blockchain, private blockchain, or hybrid blockchain. So select a blockchain platform that is suitable for the organization's specific use case and has the necessary features and capabilities. Then we have to develop a proof of concept. So build a proof of concept to test the feasibility and the scalability of the blockchain solutions, because they cannot be just like that. You can't introduce blockchain because the scalability part is also very important, and it involves cost. So then next is implement and integrate with the existing system. That's a big challenge. So we have to integrate that blockchain solution with the existing systems and processes and implement it in a phased manner. And lastly, we have to train our employees on how to use it and monitor and maintain the system for optimal performance. We will also discuss a case, if time permits, about that mobile number portability also. So that also we will see. So this is basically it is just a sort of inserting that different technologies have got the unique advantages in different ways. So by examining these use cases, we can see how each technology or concept caters to the different scenarios and offers unique advantages based on their design and functionality. So this is the blockchain in telecommunications, how we use it. So blockchain can find valuable applications in telecommunication industry. One prominent use case is in the management of MNP. So mobile number portability allows mobile phone users to switch service providers while retaining their existing phone number, as you all know. Blockchain can enhance the MNP process by providing a secure, transparent, and decentralized platform for managing number porting requests. So it's a secure, transparent, and decentralized platform, which is the characteristic of the blockchain. So it provides enhanced security also. So blockchain's cryptographic techniques ensure the integrity of user data, that means customer data, that is that telephone user data, and porting requests, reducing the risk of fraudulent activities and unauthorized porting. So the service providers cannot play with you in a way that they will not, they may not be, they will not be able to delay your request if it is genuine. And of course, at every stage, it will be checked automatically because the data is already on the blockchain. So this will, and that cannot be unauthorizedly porting also. By service providers cannot do that because they can't violate those rules which are applicable to work on blockchain. And transparency and auditability is another character which will be used for this MNP, mobile number portability. So all porting requests means mobile number porting requests which come from the customers, and updates are recorded as immutable transactions on the blockchain. That's why it is genuine, and it is not fraudulent, and the transparency is maintained. Immutability is also applied here, which we have been studying. This makes it easy to track the entire porting process, enhancing transparency and providing an auditable trail. So one can even audit it also, like has whatever has that number has been ported out or ported in, is it okay? That can be even audited also. It can be checked, it can be traced, it can be tracked also. Then what another advantage of putting this MNP request on the blockchain system is the fast and efficient porting. So with a blockchain-based system, porting requests can be processed faster, since there is no need for intermediaries. You don't have to approach any particular office or anything. It will automatically happen on the once you meet the conditions of the blockchain. To manage the process manually, the decentralized nature of the blockchain ensures that all participating network operators. So network operators here is the service providers. They are updated simultaneously, or maybe a central agency is there which takes care of all the records, throughout maybe all the service providers record in one location. I mean all the customer data. So definitely they will be one of the peers. Everybody has to participate, and there are stakeholders which are having those which are working on the nodes and peers as peers also. And what it results into is the improved customer experience. So blockchain based MNP can lead to a seamless experience for the customers who wish to switch service providers. So fast reporting and increased security inspire trust in the process. So after this use case, we will also like to share maybe few slides before we end. It is the drawback of the blockchain technology. So blockchain technology does not allow easy modification of data once recorded, and it requires rewriting the codes in all the blocks, which is time consuming and expensive. So the downside of this feature is that it is hard to correct a mistake or make any necessary adjustments. So this is a drawback. So one has to be very careful while using this technology, or maybe as a peer also one has to be more cautious, And these are the advantages and disadvantages of the blockchain. Advantage of the blockchain we have already discussed. It's immutability, transparency, censorship, and traceability. Disadvantages, of course, also we were discussing because of that consensus mechanism being, in case of proof of work, the speed and performance was low, and then implementation cost is high, and data modification is difficult. So these are the disadvantages. I don't know if you are interested, but this is just my own way of explaining. Like if somebody asks why did the decentralized network break up, so they could not agree on the centralized server. That is why the network has broken. What do you call a group of decentralized organizations? That is a democracy of companies. So these small slides I have made, but they probably are not that technical. But one can always read it if it has the time. Like I I wrote why was the computer cold, so it left its windows open. So that kind of small, I mean, just a way to understand, a way to understand. So they're like on immutability of data, how does a blockchain prove its love? So that is by staying immutable through all the changes. So immutability is explained here in a different way. And why did the hacker cry when he saw the immutable data? Because his changes were rejected. So naturally, hacker will not be able to will not be accepted on the blockchain if he tries to play with the data which is immutable. And why do you call an immutable data that cannot be changed? It is called block in the stone. And on smart contract also, like people can ask, why did the contract go to law school? So that is to learn how to execute itself, because it shows that smart contracts have to be executing. So that is why it's written like that. Why was the smart contract so good at math? Because it always followed the terms and conditions. So it shows that smart contract has to follow the terms and conditions. There are rules, So like that. Similarly, on virtual reality also, interoperability, I got the slide. And of course, now another, yeah. So this is basically hint, like if somebody wants to hold a panel discussion, what he should prepare like that. Maybe not many of you may be even interested, but then I have got the steps for that. Like before you handle that panel discussion, so you have to understand the basics of blockchain technology and its key features such as decentralization, immutability, and consensus. Then you familiarize yourself with the different types of blockchain platforms such as Bitcoin, Ethereum, and Hyperledger. Then you have to learn about the various use cases for blockchain technology such as supply chain, digital identity, and financial services. Then you have to be aware of the current trends and the challenges in the blockchain industry such as scalability and regulatory compliance. And lastly, as a organizer of the panel, you have to prepare to have a meaningful discussion with the other panelists and engage with the audience by asking open-ended questions and encouraging participation. So now just a revision. If you have time, we can continue. Like there are some 5 slides for the glossary of various items. Like blockchain, as we have already discussed, like distributed digital ledger that records transactions across many computers securely and immutability. So example is the Bitcoin. So what is cryptocurrency? So digital currency that uses cryptography and blockchain for secure transactions. So this is the difference between digital currency, cryptocurrency, and of course the fiat currency. So one should understand that. So this is the example of that. Then smart contract, we have already said, self-executing code stored on the blockchain that runs automatically when conditions are met. So the example is an Ethereum contract that releases payment when goods are delivered. So this is the supply chain. In the supply chain, this Ethereum contract will release the payment when the goods are delivered. So everywhere it is checked and then verified before the payment is released. But it is automatically done. Then decentralization, as we already said, the control is distributed across the network rather than held by a single authority. Then the consensus mechanism we have discussed, like then mining and validator, the process of verifying transactions and adding them to the blockchain, that's mining. So Bitcoin mines solve puzzles, and then of course Ethereum uses validators in the proof of stake. So wallet also we have discussed, but it is a digital tool to store, send, and receive the cryptocurrencies. Examples are MetaMask, Trust Wallet. They are the suppliers of the wallet. Then token, as we already discussed, it's a digital asset built on an existing blockchain, can represent currency, rights, or assets. So example is USDT and UNI, the DeFi token and the stable coins. NFTs, we already discussed, a unique blockchain-based token representing ownership of the digital or the physical assets. So digital art sold on OpenSea. OpenSea is also another platform. So NFTs are used there, So DAO is the decentralized autonomous organization, which is a very famous term. So these are the community-led organizations governed by blockchain-based rules. That is through smart contracts. Like example is the Maker DAO managing the DEI stablecoin. So this is the probably last quotation, that whereas most technologies tend to automate workers on the periphery doing menial tasks, blockchains automate away the center. Like for example, instead of putting the taxi driver out of a job, blockchain puts Uber out of a job and lets the taxi driver work with the customer directly. So this is the power of blockchain, you know. Instead of putting the taxi driver out of a job, blockchain puts the Uber out of a job and lets the taxi driver work with the customer directly. You know, so this is how the centralized control is done. You know, it's done away with. So thank you very much, and once again, thank to my colleagues, my audience, my fellow members here for a very patient listening. And this subject is so much popular and so much vast that it's very difficult to complete it in 1 hour time. But still, I've tried to cover whatever I little I knew about it, and I look forward for more such sessions. Maybe any details of the same this thing, or maybe on sustainability. Also, we can talk of SDG 2030 mission. Also, that is sustainable development goals are there. So we work for emerging technologies in case of even the circular economy. We already know about that. So the point is that we can club together, collaborate, and achieve. Like the Viksit Bharat target is there by 2047. So a lot of things are happening in that. Our economy is also growing, and one of the top economies we are becoming. So thank you very much, and looking forward. May I end the session now? Hello.
Yes,
Yes,
sir.
sir. Sure.
Yeah.
Okay, sir. Thank you. Thank you very much, sir, for your wonderful presentation on blockchain, beyond Bitcoins, applications to build trust and transparency for sustainability. Now, I would like to invite Honorary Secretary, IEI Salem Local Center, to propose vote of thanks. Ma'am,
So thank
please.
you, sir. Am I audible, sir?
Yes, ma'am. Yes.
Most respected chief guest and the keynote speaker, Dr. Lap Singh, sir, and our respected chairman, Dr. K. Tangraj, sir, Mr. Arumugam, sir, committee members, respected committee members, state center and local center, various fellow engineers, students. It is my distinct honor and privilege to deliver the vote of thanks for the today enlightening seminar on blockchain beyond Bitcoins. This is 94th seminar webinar, special webinar under the aegis of Computer Engineering Division Board. First and foremost, I would like to express our esteemed speaker, chief guest, Dr. Lap Singh, sir, ITS past chairman, PCSC, IEI Chandigarh, who have shared their invaluable expertise and knowledge, the discussion on the application of blockchain in supply chain management, the future of decentralization finance, the use of smart contracts in the legal sector. So it is informative, also opened our minds to the vast potentials of blockchain's technology beyond its most famous applications. Their presentations have been a true source of enlightening for all of us. Thank you so much, sir, for your dynamic presentation for 1.5 hours. Thank you so much. Our heartfelt thanks to our beloved chairman, Dr. K. Tangraj, sir, for organizing like this useful webinar for our students community and engineering fraternity. Thank you so much, sir. I extend my sincere thanks to our engineers team members, Dr. R. Satish Kumar, sir, Dr. Kumaravel, sir, Engineer Arumugam, sir, and K.S. Selvam, sir, for their continuous guidance and support. It's my privilege to thank Engineer Arumugam, sir, for his continuous support for our IEI. Thank you so much, sir. I would like to appreciate Mr. Thiago for organizing this seminar in a successful way. In closing, the seminar has demonstrated that blockchain is not just about cryptocurrencies. It is a transformative technology with the potential to revolutionize the countless industries. The journey of exploration has just begun. Thank you once again for all making this seminar resounding success. Thank you, one and all, sir.
Thank you, everybody.
Thank you,
It
sir.
was
Thanks a
clear
lot.
for me
Thank you
also.
so much, sir.
In fact, I will
Thanks.
just request you that if
Thanks.
any participants they want to contact me, so my mobile number and my mail is also given. That is the labsingh@gmail.com. And because we encourage students to become members also. I'm there as advisor in the Blockchain for Productivity Forum in Delhi. That is a apex body, and we invite the interested students, scholars, and faculty to become our members as well, or maybe if they want to hold some event, we provide resource persons as well. So it's a NGO, and I would invite anybody from the participant to be in touch with us, and we will try to do our best to create an environment for the development of blockchain technology and its expansion in various sectors like health and agriculture, and then education, governance. Everywhere we have a network, good network of that. So my phone number is 94, as you already know, 9469797979. 9469797979. So you can note down, and we will be happy to help the participants. And in your feedback form also, I think you can always make a list of the participants, and we can use that list for propagating our utility of the emerging technologies, including blockchain. Not only that, it is even IoT. We can talk of Web3 also. So thank you very much once again, and we are open to discussion or any feedback. It will be nice to have take it forward. Thank you very much.
Thank you, sir. Thanks a lot, sir.